All right, awesome. Yeah, do you want to run this one, Limin, and I'll take notes, or do we have somebody else that can take notes?
I can take notes.
Okay. Cool. So is everyone able to see the agenda document? I can share my screen. There you go. Are people able to see the security policy notes?
Yeah.
Yes.
Awesome. Agenda and notes. So what we have on the agenda is basically kind of running down a couple of updates on the P0s and P1s that we discussed at last meeting. And then there is a kind of more general, kind of forward-looking policy proposal that Wenjing put together, which we will discuss. So Diep, are you on the call? Do you want to give us an update on incremental MTLS adoption?
Okay, I think just a recap of all the discussion happened in the last 2 weeks. So for the plan that, for the incremental plan that we based on multiplex, it could be, we still need to work on that, but it could be P1 because of the multiplex may involve some dependencies that we not aware of 2 weeks ago, as well as there also
so I don't think we talked about multiplexing with this group. So just to kind of clarify for people on the call, the idea was that we could build support in Envoy to have a single listener be able to accept both MTLS or plain text connections, and that would allow us to kind of incrementally roll it out without introducing new ports or service interruption.
Yes, thanks, Spike. So with that feature, we're able to have a fast rollout. With the traffic shifting, we need to work further to find the good way to specify the configurations. So that's still work in progress, and but we put it to P1 or maybe even further. At the same time, we want to use annotation for now to provide per service enablement and provide the traffic shifting, not really traffic shifting, but traffic migrations by adding annotation to create a new port for the migrations. I will put the the link of the design doc into this. It's an old design doc, but like it's changed a lot.
Like annotation?
Annotation in BP0.
Did we get a chance to discuss this proposal design in this group yet?
No. Do you want to do it here now?
I think this proposal probably in a more ready state to be discussed than the authentication policy proposal I have, which is forward-looking.
Okay.
I have a slide, so I can do that.
Okay.
Quickly, hopefully in 15 minutes.
You're presenting, right?
Yes.
So DM, are you to present?
Yes, I'm trying to connect. So this is mostly what we want to do for P0 for 0.3 release. So the first one is we want to add the annotation to enable authentication per service. We use service annotations, and here's this example, but I think so basically we have annotations that say what policy you want to apply on this service. On the APIs, the enum we have in the API right now, we're going to add a new enum that indicates this is indicate it should use the parent scope to a policy instead of that policy. I'm sorry, it's not very clear, right? So for the API, we're going to have a third enum that define the policy should be used, the parent policy should be used instead of that level, of that scope level.
So what are the parents?
So thinking of like, so the parent of service, for example, could be a namespace, and parent namespace could be a mesh. So right now we don't have namespace yet, but like just the higher in the higher level in the hierarchy.
So if it's not defined, it's using the parent
Yes.
policy. Okay.
Hi, this is Len. Can you guys hear me okay?
Yes,
Yes.
yes.
Okay, so before we get into the detail, let me just ask on the big picture thing. So today with Istio 2, user have Istio auth and Istio.yaml file. Are we thinking with this proposal, it's just going to be consolidated with one YAML file? And by default, the mutual TLS would be disabled for every single service unless the user actually turned on this annotation in their service and they can enable by a particular port. Is that the idea for this?
Yes, so the idea is you can enable or disable per service port, override the mesh policy.
But by
Override
default,
the global.
everything would be not mutual TLS enabled unless you have this annotation?
No, so if you don't have the annotation on the service, it's use the mesh policy. So the mesh could be mutual TLS at that time, so everything will use mutual TLS.
So there are two YAML files, as I remember. One is with auth turned on, with the other one is auth turned off. With auth turned on, I think the mesh level is assuming mutual TLS turned on. And if you apply this per port policy, you can turn it off.
So are we saying with this proposal, users still going to have two YAML files? Because I thought we were trying to get rid of two YAML, so user always install one Istio.yaml, and then they could enable mutual TLS as they needed.
That is the migration strategy. So yes, user can just only turn mutual TLS on the mesh level and disable that on the service that not work, that not fit with the mutual TLS. So, but in the beginning, when they start to use, they can start with the mesh without mutual TLS and turn the service by service, just to be sure for the slow migrations.
Right. I also want to add that, like, if the configuration is not about a single YAML file, if I understand correctly, we're gonna separate them to different CRD files. So each CRD file may have different responsibility. Like RBAC will be yet another policy config.
Yeah. So my understanding is, if we introduce this annotation, we are going to replace the previous configuration. So the YAML file won't apply anymore.
Yeah, so I think regardless whether the
no
YAML file apply or
happens
not, the question still remains, do we still have two paths for the user as they start with Istio?
But what do you mean two paths of users?
Because today, if you look at our document, there's like two paths. If you need auth, do this. If you don't need auth, do that.
Oh, I see a point.
Can I say something?
Go ahead.
Yeah. So currently we have Istio.yaml and Istio-auth YAML, and eventually we'll definitely get rid of two. I mean, we only keep one, but either we go from default turn on Istio cluster-wise enable auth or disable auth. That's a product decision, but eventually we'll have one, and the user can gradually, if it's disabled by default, user can gradually enable service by service. The other way is also they can disable one by one.
Okay, so this proposal is useful only when the mutual TLS is globally disabled for the mesh. Is that
No,
the
it
right
can be used for
assumption?
both. Thinking of you have a opt-in or opt-out option, right? So your strategy could like you want to turn on TLS for the globally for the whole mesh, and then turn off one by one on the service that not work with TLS, or you can also start with the mesh that disable TLS globally, and then turn on the service one by one. So it is the operations decision to choose either way. The annotation basically provides a way to override the mesh policy.
Yeah, so if I have mutual TLS enabled for the mesh, then I don't really need this particular annotation because mutual TLS is enabled by default.
Yes, that's right. But you
That was
need
my
this if you
confusion.
need to turn off TLS for some service that doesn't work with mutual TLS.
Okay, but then you kind of turn it off for the mesh. I'm just saying, as a user, if when I use this annotation, it's more useful when the mesh is actually off for
So
mutual
maybe
TLS.
I think what we are confusing probably the term mutual TLS. If we can turn on mutual TLS, I mean, for both client side and server side are running Envoy, that should work. But I think this is trying to solve the problem that some either client side or server side doesn't have Envoy. We could not turn on TLS. Is that what we're trying to solve here?
Yes, and for the case that service already has a TLS that you cannot use mutual TLS on top of that.
Right.
And the other thing is the health check, right? So if I'm doing my health check for my services on port 8080, then I don't want mutual TLS enabled. So having this annotation allows me to say, you know, I only want to enable maybe on 80, but not on 8080. So I can do my health check without Istio inject the mutual TLS flow.
Yes, yes. So this could help to solve that problem too.
Okay, so with that, I think there is a use case, even when mutual TLS is enabled for the mesh, I could potentially still need this type of annotation if I need to have like a health liveness check, right? Because this annotation, like you were saying earlier, essentially is going to override what's being configured at the mesh global level, which is always enable mutual TLS for every single port. But then if I want to open up mutual TLS only for specific ports, that's one of the reasons I would use this annotation, even when mutual TLS is enabled globally for the mesh. Is that?
Yes.
Did I get it right? Okay, thank you.
Yeah, I'm sorry, I'm kind of cut the problem statement on when I present this because I assume the different set of audience. But yeah, I will send out the link for the design docs that will be maybe clearer. So this one is just like present the decision we want to do for 0.3.
Right, I think I definitely echo like confusion. Are we sure mutual TLS is right enum?
So right now I use the enum that existing in the current API, the authentication policy.
Okay.
But in future we can change or if have a new different type enum.
Because this is mostly controlling the server side, whether this port should host the TLS port or plain text port. In the future, we will support like multiplex, both TLS and plain text. We may, figure out a way to accommodate that.
True. I think the authentication policy enum or API will change in the future. Okay. We may have a different like server only, client only as well, but that's TBD. So that for service, so that is have to enable or disable TLS on the user service. For the control service like API server or some Kubernetes control service, we cannot put the automation on them. So the approach is we add some field in the config map to say this service should not be used TLS.
Wait, I don't think I understand. I thought that the way that you would turn off authentication for services is by annotations.
But that only, you can put annotation only on the user service, that when you have a service YAM file, right? For API server, for example, you cannot add the annotation on, on that. There's no such a thing. So to identify, let's say this is API server, so do not use TLS. You have to specify the service name or namespace that is in.
Oh, this is for Kubernetes services?
Yes.
Okay. Yeah, and I envision we would use this for some of our own Istio services, like our pilot or ingress, right?
Yes. So any kind of service, control services that, or any kind of service basically that you cannot put annotation on, this is the workaround. So we add a new field for the config mesh and add the service name that you don't want to use authentication, or even namespace that you don't want to use authentication.
So if we use a CRD approach, would that be more consistent than this annotation-based solution? I'm just curious.
Possibly, yes.
Okay.
So for health check, let's go back with so one, we can use annotation to disable the port for health check, but if that port is shared with like regular service, then that equivalent to disable TLS for that service, right? And that may be not desirable. So we also want to see what the better way to do this for kind of service management requests. So one option is we do nothing and wait for the envoy multiplex that can support both TLS and non-TLS on the same port. So we can configure filter or mixer to allow only health check on that port. Plain text health check on that port. And that is the ideal solution, I think. But the other approach is also change the Kubernetes inject to change the health port to some dedicated port and configure use pilot to route that port to the regular health check port from end of the app, or change them to curl command, which is the current workaround that require operator to do that manually. So just list out the option here just for discussion. I think right now we may using option 1.
Oh, okay. Questions?
Wait, does that mean that we have no solution for health check for 0.3?
Yes and no. A quick one is disable them. Disable TLS for health check.
Right. So basically, if you need a health check on a given port, you disable mutual TLS through the annotation on that port. So user can still leverage health check, right?
Yes. And
but only if their health check is a different port than their normal service port.
That is true, unfortunately, yeah.
Or they could do some workaround. The core workaround, I think, still works.
Yes.
But it's not perfect, I agree.
What is the current workaround?
So instead of specify the HTTP GET, they change that into a curl command, a kind of a command that is in curl to query the local query that port on the local host. Because health check, you can run any command on the port, right?
There's 3 types to do health check. One is run command, the other HTTP GET, and the other one is like TCP check. And I think that the recommended solution is actually the curl, based on my understanding. And we are documenting how to do that.
And does that mean we're including curl in like the Istio proxy container or something like that, so that people can execute this?
I think so.
I think we have to do that.
Because you can't assume that curl is going to be available in the workload.
Right.
container.
You're right. You're right. We have I think we have the instructions for that.
Okay.
Okay. It's not
Yeah,
perfect.
that's basically the workaround for 0.2, right? If you need health
Yes.
check, you have
You're
to
right.
run it locally. Yeah.
And I think the multiplex should be coming soon. Do we have like ETA?
Well, I mean, I think the claim was that we're going to wait until we're on the V2 Envoy APIs before we get multiplex, and that we're not able to kind of say with certainty that that'll land for 0.3.
Okay, I think in terms of 0.3 release, we probably need to think up what that mean.
I mean, that's why I say we do nothing when wait for it multiplex. Hopefully, you can get in time. But
yeah, let's take this offline, and I mean there might be some change. That's what I can say.
okay. So for the second objective is we want to extend the annotation for traffic migration as well. So just recap the problem. For traffic migration, you want to provide the mechanism for customer to switch from non-auth to auth without any downtime. So in this plan, we want to provide a way for customer to specify an extra port that they can route the traffic to that port using TLS, and then upgrade the original port to TLS and move the traffic back to the original port. So the annotation basically you want to provide a richer information. For example, we want to specify what port is equivalent to the original one, what is authentication policy you want to use on this port, and the state, which means like is the traffic should be use this one, or the server you just create the port on the new port on the server but not accepting any traffic yet. To clarify, let me go through how the user will use this to migrate the traffic. So first, we add annotation to say I want to create a port 88 equivalent to port 80 and using mutual TLS, but not accepting any traffic yet. So the state is idle. So at the runtime pilot, we create a cluster, a new cluster and listener for that port on server and on client side, but there's no route rule going to that, go through that port or class, go through that cluster and listener yet. The second step is they change the state to active. So now the server already has that port, and when they change this active, the pilot start routing the traffic, goes through the port 88. It can take few seconds, minute. It doesn't matter, but because like the original traffic goes through 80 still available, so it's no downtime when they switch over. Once it's done, if all the traffic goes through 88, they can upgrade the original port to mutual TLS now. Again, this no off because there's no traffic goes through this the original port. The fourth step is just do the opposite. We switch from 88 back to 80 by annotate the port 88 now became idle. So the traffic switch back to port 80, which is now using TLS. And the final step is just remove the old, the new transition port.
Are you saying these steps is what's happening for the system under the cover that user doesn't? Are you saying user have to manually do this?
User have to go through this 5 steps in able to complete the whole transaction, the whole migrations.
Okay. I think it sounds pretty painful, and it wasn't very clear to me in some of the step in the middle. I think it was 3 or 2 that how you actually indicate like the target port and the source port.
What?
Like for this one, how is 88 the source port and 80 is the target port that the service is listening, or is 88 the old port the service is listening, and the 80 is the new one you are moving to?
So 80 is the
Yes.
is the old plain text port, and then there's a new aliased like TLS port called 88, or like port 88 gets opened by the Envoy, which is for TLS traffic.
Okay, so 88 is the new one. Now, does the user have to change their code to point to 88?
No. That's all done in Envoy.
Okay, so that's
So when
okay.
you flip the state from idle to active, that signals the client-side envoys to start using the new port, the TLS port.
Any particular reason to switch port? Is that to try to avoid this downtime?
Yes.
Okay. If user don't really care about a small window downtime, could they have like an easier user experience?
And they just fix a bit of mess.
That's it.
Yes, that's it.
Okay.
Can you clarify if user needs to change their Docker image? I assume they don't have to open up 88 either.
No. So 88 is like this annotation just to tell pilot or envoy to create a new listener on that port. They have to choose this so that's not conflict with any existing service port. But no change required on the Docker image or the application at all.
Okay, so basically Envoy opens up that port, and because the fact that Envoy runs on the same pod as the actual microservice, so we can't make sure, we have to make sure it's a port that has not been used by the service. I see,
Yes.
okay.
Do we have a rough idea if for users they don't care about the short window downtime, like what would be the short window downtime if they just switch the bit at the mesh level?
I think it depends on how big is a service, right? If they have like 100 or 1,000 of microservice that cross the global, I don't know. It could take a few minutes.
What about like it's only the short scale, small scale of services?
I mean, I think that like anybody who's like running in production, like downtime's not acceptable. So if we don't provide a way to do this with no downtime, then they have to consider some other higher layer as a way to prevent downtime. Like they have to go up to their load, whatever their cloud load balancer is, and then switch from one Istio cluster to another. Basically, like anybody who's in production, like you just can't have downtime. That's like almost not, like no one does that, right? It's not like Slack. It's like, oh yeah, we're gonna just shut down Slack for 5 minutes.
Production, I agree. But if I'm talking about some people that just want to do some load test or canary, I guess this seems like a little bit more complicated than I thought to be.
Yeah, I think you're going to have a hard time to demo this too. And for production, I agree, that's what we are trying to achieve, no downtime. But I wonder if there is a way we can roll out the configuration to one instance at a time. So maybe, let's say if I have 3 instances, maybe I take one down instead of all 3 down together, then that type of downtime could be acceptable, right? If I'm only take 30% of my traffic down.
Do you really mean 30% of your traffic goes down, or you mean 30% of your instances go down?
I guess I would say 30% of my instances,
Okay.
and that's an edge service, right?
So we put some thought on put the annotation per deployments and using traffic the routing rule to shifting traffic. But I think the decision now is like waiting on multiplex and see how the route rule can do it better.
Yeah, so like once we have multiplex, then we don't have to futz around with all these like these extra listeners and things like that. You'll be able to open up a single listener that could accept either plain text or TLS connections, and then you can sort of roll clients over from the old port to the new port, basically just as fast as you want as the operator.
So I guess what we're trying to say that ideal solution is going to be multiplex port, and we will provide user better user experience. But at this moment, at least we have solution for customers. It might not perfect, but at least there is one. Otherwise, they don't even have any solution to enable Istio without downtime.
Oh yeah, we're not saying this is not good. We're just brainstorming to see if this can be
right. I also
sorry
if
it come across that way.
So we agree like this approach is like for very paranoid users that like don't want to multiplex because we are sniffing the package or they have some firewall that preventing that. Or they want to know exactly what happened. So I mean, for that user, this may be a good approach, good enough. For people who don't care about downtime, they can flip the bit. And for the middle, we working on that still.
Yeah, makes sense.
Is it possible we provide some kind of scripts to run through it?
Well,
we need to wait for the
would
traffic swing.
For multiplex.
Yeah, they have to wait for traffic.
Can is it possible we just always say this particular port is reserved and we don't recommend you to use it instead of asking user to pick a port? Because I think that might be a little bit more confusing.
Yeah, I think we can put some suggestion, but I mean, we can put some recommendation of ports to be used to avoid conflict, but it's not a strict rule in my in my thought.
Yeah, I mean, I think that like if you go down this path of like trying to automatically pick a port, then the edge cases are gonna just drive you up the wall there. I mean, because this solution where you've got multiple ports already needs to be coordinated with any network policy in Kubernetes or any firewalls that you might have. So like having it pick this stuff automatically is I think going to be a nightmare and kind of not worth the effort.
Yeah, I'm not saying automatic. I'm just saying, let's say we just say reserve this port 1, 2, 3, 4, 5. It's for mutual TLS enablement. We don't want people use it. Like pick a really odd port number.
That seems reasonable.
But what does that gain us, right? Like then you
they don't have
this port.
Yeah, it would simplify the annotation here, right? Because then you don't have to specify port. And I don't know if we have more policy than mutual TLS.
Well, we also have the state, right? So I mean, you still have to have
state
this
is pretty much the only thing, yeah.
I'd rather have this explicit because like they may have the service that have more than one port, right? So they need more than one port for the migrations.
Oh, okay. So each port, they have to pick another port? Like yes, if I have 3 ports, okay.
Because otherwise, like, because we need to know where to route the requests when they come in over the TLS. Like you can't then sort of break out the traffic back to the 3 original ports that the application is expecting.
Mm-hmm.
Yeah, I think that's all I have. I will add the link into the meeting notes so we can have more comment on the design up, have some more background and other alternative discussion we went through. Thanks.
Well, thank you. Good stuff.
Any other questions or comments on mutual TLS?
Yeah, I have a quick question on the side. I don't think it makes sense to enable this annotation for my edge service. Is that a good understanding?
When you say edge service, you mean something that is going to take traffic from outside the cluster?
Yeah, like product info as example, product page for the booking info example.
Well, I mean, the product page, like service, is entirely in the mesh and gets a connection from the ingress proxy, and so that would be protected with mutual TLS. The connection from the ingress proxy to the product page service, but the connections coming to the ingress proxy will typically not be mutual, or we don't have a solution for the ingress proxy to have mutually authenticated TLS listeners.
Right. I think that what being presented here, typically assuming both client side and server side has Envoy, as you can see in the diagram. And I think edge typically will mean ingress, no? Like it's external clients calling into your service. That's why we call it edge. And that's probably not covered in this scope at this moment.
Okay, yeah, thank you for clarification. I think it's pretty clear.
Yeah, I mean, I think that like you are going to have people that are migrating some services to Istio, but there will still exist clients maybe inside their cluster that are making calls to that service that are not integrated with Istio. And so this dual port solution sort of gives you that ability. Can do mutual TLS, so you can just kind of hang out in that state where you've got both a plain text listener and an MTLS listener. So all of the traffic that's inside your mesh will be encrypted, but any legacy clients that are not yet integrated into the mesh don't break.
Right, that's an important scenario too. Yeah.
Yeah.
Okay. Thanks.
Okay, now we can move to the next topic. Yeah, so for Istio native RBAC, so for last weekend, I was trying to focusing on how Istio RBAC can converge to Kubernetes RBAC, and I had a discussion with Spike, and we had a rough proposal, and we talked to Kubernetes folks about the convergence plan. So
only Google Kubernetes team.
Yeah, Google Kubernetes team. Yeah. So the current from the feedback we have got, I think the current plan is we will mostly keep the current proposal. Basically, we will make small changes, like the name changes, probably from Istio role to service role or some kind, the name. But mostly it will be the same proposal. And the plan is we will implement this Istio RBAC as CRD custom resource initially for Kubernetes, and later Kubernetes community may decide to include Istio RBAC as part of the standard resource. But the plan is not finalized. I'm just giving an update here. We will still continue with discussion with other folks and the broader community, including the Kubernetes community. So once it's finalized, I will send out an update for the finalized spec.
That sounds like the right approach to me. Even if the Kubernetes community was bowled over with the proposal and really liked it, they'd almost certainly want to start with prototyping it with CRDs anyway. And so I think kind of decoupling ourselves from that process will allow us to keep moving forward quickly.
Yeah, that's a good point. Yeah, we also want to finalize the plan quickly and try to move forward to get this implemented. Yeah. Okay. Any other comments or questions?
You mentioned that you were talking about possibly changing some names. Like, what were your thoughts there?
The possible changes, most changes are just on the wording. Change Istio role to service role.
Okay.
And also the permissions may change to rules. Yeah, it's not big change.
Yeah, I think there are also some thing we need to figure out. I mean, as outcome of last discussions, like in terms of verb vs method, how does JavaScript method map to HTTP method, and how does these two, correlate to each other, so such that we can define consistent ACL policy. And the other thing I noticed later is it's possible for us to predefine some default role, like editor role, admin role, and that could be reused among different services, just like what we can see from Cloud IAM. And that will greatly simplify user experience. I don't think we have explored too much on that direction yet. I would like to see some examples, if it's possible or not.
Yeah, I think most of the action items were on Kubernetes with respect to figuring out what it was going to do in the future. But then making sure that, like, we talk with non-Google Kubernetes folks to either agree or disagree on like what their directions would be, so that we get clarity on like how the Istio RBAC would remain future compatible in light of upcoming changes to Kubernetes to support gRPC, for example.
Right.
Yeah.
Actually, just learned earlier today that they are building support for aggregated roles. So roles can basically include references to other roles. So you can create a role that is like the kind of union of all the permissions of a couple of other roles.
Oh, is that a new released feature?
It's not released yet, but this is coming down the pike. So I think it probably maps straightforwardly to the plan that we have, that we could add that in the future if we wanted to. But it's probably worth doing a little bit of a thought experiment about whether that would work for us.
Right, and I still not clear the use cases this aggregated role could buy us.
Well, it's more about like policy reuse. So like if you have some set of terms or definitions and you don't want to have to redefine them in multiple locations, so it's you get like an inheritance model among your roles by being able to refer to other roles. Inheritance through composition, but like that's effectively what it is that they're offering.
Oh,
yeah.
Okay.
So Cloud IAM chooses inheritance. Basically, it can inherit the parent role, but Kubernetes chooses aggregation, right?
Yeah, the composition ends up usually being much clearer because the developer understands what those references are, rather than having some underlying system make the decision for you.
I see. Yeah. So Spike, do you have any link to the design doc or some?
I will send you a link to the PR.
Okay. Thanks.
So could you click the link? Okay. Is anyone presenting? No.
Oh, I think Spike is presenting. Oh no, not right now.
No, I mean I can. Or when do you want?
Yes, I can present.
You can drive.
Sure. We only have 10 minutes. I'll probably just quickly go through what we're trying to do. Policy meeting. Okay, can everyone see my presentation, my slide? Sorry, my dog. Okay. So these are mostly forward-looking proposals. So this could, you can imagine this as a follow-up work as from what DM and Spike is doing. So currently, we are mostly talking about how to enable authentication for mutual TLS. But beyond that, we also want to cover other authentication type, as I listed here, as well as how does legacy application that doesn't use Envoy talk to service using Envoy. Beyond that, we also need to figure out authentication policy for end user and impersonation. When end user is involved, the authentication policy will become much more complicated. And I think we need to describe a good policy to specify how to configure them. I will just quickly go walk through the general proposal. and this doc is still work in progress. I'm not sure if it's not like entirely ready for review, but early feedback is welcome. So instead we have using annotation to define mutual TLS or non-mutual TLS. Here I'm proposing to use a CRD, just like how do we define authorization policy, so we have consistent story. So add a new kind called authentication policy, and also so the metadata is the same in the spec. We added we are proposing security level. So security level, you can specify minimal security level. That could be plain text. And in the future, we could add like TLS without encryption or TLS with encryption. And max security level is just adding here for completeness. If you want pure plain text port, then you can specify both min and max to plain text. And security level could be applied at the namespace level, at the service level, and at the port level, and even master level, if you have use case for that. Other than security policy, there are two more sections. One is credential policy. Basically, we want to describe what kind of credentials client need to present. Either certificate, we can set up mutual TLS, or client can just present a JOT token or other authentication token. The next section is about impersonation.
So what do the allow denies do in this?
I have some example, like in the following sections. Let me go there.
I guess like I am wondering to what extent like we're reproducing what would be done in an authorization context.
Right. Authorization doesn't only have allow, right? It doesn't have deny.
Well, RBAC.
Sorry, RBAC. Yes, I mean authorization.
But authorization in general, like could be designed to have allows and denies.
Do I have deny example?
However,
yes.
Kubernetes RBACs are grants only, they're not denies.
Yeah.
Right.
So the question is, what is the default behavior if you don't have any policy? Is it default by default allow or deny?
That part hasn't been like spec'd out yet, but allow basically means whether we allow the client to, whether we allow a client that present us a like sorry, what is that? If the client doesn't present any credentials, do we allow this or not? And that's the exam, the first step here. So at the beginning,
like it sort of feels to me that really is stepping into authorization, right? Like to have the policy be like, I'm going to deny connections that don't have credentials.
Mm-hmm.
Is it fitting into authorization model?
You actually call it permissions, so you can call it authorization. But that's
I'm not sure about this part. So I think that perhaps something we need more discussion. But again, this is just most presenting the use cases here. I think we need a way to describe the case, like if client doesn't have any credential, do we accept them or not? If that belong to, whether this belong to authentication or authorization, I think that's debatable.
Yeah, I think there's a weird overlap where basically the authentication rules describe the principles that are permitted, but there's like a window in which you need to carve out exceptions. And I think that's why you see the allow deny sitting inside the authentication.
Right. So yeah, we can have more discussions, but let me just quickly run through the use cases. I think that's like the first step is assuming we have multiplex support ready, and we could set minimal secure level to plain text. That means each service can accept both TLS and plain text traffic, and we allow clients without any credential. And client could come from either Istio client that has Envoy running or legacy client doesn't have Envoy. That's where we start. But we do encrypt. We don't have encryption at this moment. And moving forward, the second step, we could enable mutual TLS between Envoy clients and between Istio client and the Istio service. And what we need to do is to change the permissions from no crest to use certificate for Envoy clients, but for legacy clients, they can still talk to Istio service without presenting certificate. And if we want to do that beyond just between Envoy and Envoy, we could actually change legacy client to also require presenting certificate, assuming on the server side, Envoy will take care of the TLS termination.
But how would you get the certs onto the legacy client?
Yeah, that will require application side change. Application need to hand off the certificate to Envoy. I mean, if application want Envoy to provide L7 features, otherwise there's nothing Envoy can do. Envoy can only do L4 level capabilities.
Okay, so not only application has to be able to handle the certs, I assume you also have to maybe install the certs onto your legacy service? Okay.
Well, we could automate this, certificate installation, like integrated with Let's Encrypt. If customer want Envoy to handle this public certificate, that is doable. Same thing, if we want the mutual TLS from legacy clients, then we do another change to increase the minimum secure level to TLS. Other than that, there are more areas we need to explore, like client authority. This is mostly used for impersonation. If client is a service calling on behalf of users, then typically we would like this client to indicate which credential should be used to enforce authority, whether the service itself or the user is calling on behalf of. And I'm listing a number of impersonation scenarios that we learned here, and I'm not going to go through them here. So any questions?
So with this authentication rule, does that mean I, as a user of Istio, I can set different rules for authentication for different namespace, and I don't even have to bug the cluster admin to be able to do the changes for me if I'm the admin for my namespace?
That's a good question. I think we need to figure this out not just for authentication policy, for any policy, including authorization policy, who has access to edit these rules. And we probably need to define different levels of operators, like cluster operator, mesh level operator, service level operator, are definitely not users, I think.
Right, I guess I was just giving an example, but yeah, I think you got my point.
Right. That's part of what we're missing.
Yeah, there will be an ACL policy defined to say who can modify this policy.
So right now we only have one role, which is admin, super powerful admin. And I think that might be sufficient for small customers. For big customers, like based on experience from Google, we typically have different roles. Like we need to have service operator. They can only operate the service belonging to that team. And they cannot modify service that doesn't belong to them. Same thing for ACL.
Yeah. So
And you typically have admin for a given namespace, which you don't necessarily need to bug the super user.
Yes.
Yeah. Set permission itself can be a permission. So in Kubernetes, it has the bind verb, which can be used to say you can use this bind verb for cluster rows, cluster row bindings. So that basically assign you the permission to define the to define the access control policy.
Okay, I think we are out of time for this week's meeting.
Yeah. Right.
Yeah, good discussion. Thank you, guys.
Bye.
Okay, thank you.
Cheers. Bye.
Bye.